Hello Legacy students. So today we're going to talk about natural logs and E. So you're going to need your notes, that foldable I gave you in class, pen or a pencil, and then you're going to definitely want a calculator today just so you can find the certain buns I'm talking about. So what is E? Well, it's not just the fifth letter in the alphabet. It's also called Euler's number. That's what it's referred to. It's a very important number, kind of like pi. It is a irrational number. It continually repeats. It does not repeat, but it is a never-ending number. Roughly, E is 2.71828, 2.72 basically. It's one of the most important numbers in mathematics, along with pi and I. It's one of those numbers that show up quite a bit in real life. That's why it was designated a specific name for it. Now, what can we do with E? Well, you can actually graph exponential functions with a base of E. Very similar to when we graphed exponential functions with a base of like 2. You first need to find your parent table. So my parent for this particular graph would be y equals e to the x. Okay? Now, what I need to do is make a table for e to the x. So -1, 0, 1, and 2. So if I go e to the negative first, so that means I would go like 2.72 to the -1. Well, your calculator, if you find the ln button, right, should be right below your log button, you should be able to somehow get to e to a power. So if I go e to the -1, I get a decimal equivalent of 0.3679 roughly. E to the 0, that's 1. E to the first, that's 2.72. And then e to the second is 7.389 roughly. Okay? So same things apply though. So this is a stretch. We're going to know that 2 to be a stretch. So that means I got to multiply each of these numbers, unfortunately, by the number 2. And then I get to subtract 3 because this is a left moving, right? Because it's up there, it's opposite for the x values. So I'm going to move left 3. So let's fill out our new table here. So -1 minus 3, that's -4. 0 minus 3, -3. -2, and then -1. So now I need to know what is 0.3679 times 2. That is 0.7358. This is 2, right? 1 times 2. I need to know what 2.72 times 2 is. It's 5.44. And then 7.389 times 2, that is 14.78. Now what I can do is graph those dots. So -4, decimals, -3, 2, -2, 5.44. Oh, that's not it. Silly Marsh. That's not where that graph would go. 5.44. There we go. And then -1, 14, be like right up there. So it would be something like that. So this would be a growth graph, if you notice. Asymptote would be y equals 0. My domain, -infinity to infinity, just like all of the other ones. And my range from 0 to infinity, because I can't touch 0. There is an asymptote located right there. Now, there is something special with e's. There's a negative in that exponent. Notice, guys, that's different. You guys haven't seen that before. Okay, what that does is that's going to change not the y values to be negative, like there used to be a negative in front here. That's actually going to change the x values. It's a reflection around the y-axis, not the x-axis. Something a little different. We haven't looked at that really in this class because that didn't really change most of the graphs we ever looked at. So my parent would still be y equals e to the x, still the same parent table as last time, which you'll probably be able to copy. I really can't. -1 is 0.3679, 1, 2.72, and 7.389. Stole that from my calculator here. Now, this is a reflection along the y-axis, not the x-axis. So that actually is going to make all of my x's be multiplied by -1. Basically, what I'm doing is just flipping this guy around the y. Then I'm going to add 1 to each of my y's. So I'm going to get 1, 0, right? Because 0 times -1 is still 0. -1 and -2. If I add 1, that'll be 1.3679, 2, 3.72, and 8.389. Okay, so let's graph these dots. So I got 1.136, 0, 2, 0, 2, -1, 3.72. This is kind of awkward going backwards here. -2, 8.3 something or other. There we go. So if I do my graph here, looks like I got an asymptote at y equals 1. Notice, guys, this is a decay graph. The only way that e's can be decay is because of this negative exponent. And think through that. Why is that? Well, if you have a negative exponent, technically this is 1 over e to the x, right? That's the equivalent of that. That would be why we get a decay graph, because this is a number less than 1. So that causes me to get a decay in my particular graph. So I get decay here. Got an asymptote of y equals 1. Domain is -infinity to infinity. My range would be from 1 to infinity. So that's all good about e, but what about ln? Well, just like when we talked about common logs, which was a base of 10, that was the log button, there is such a thing called a natural log, which is a base of e. So log with a base of e, so log with a base of 2.72, would be known as a natural log, an ln. And knowing how to work with them is very important. So, grab out that foldable that we have, natural logs with a bunch of e's on there. So what is in fact a natural log? Well, a natural log is just a logarithm with a base of e. It's the inverse of y equals e to the x, if you want to think of it that way. The abbreviation is ln without a base, but you know that should be a base of e, so it's not uncommon. You could put the little e there if you need to, but it's more common that you're just going to see an ln there. So, converting between natural log and exponential, this is in the inside of your foldable. So I need to know how to convert. So if I have ln of smiley face equals $, well, notice, guys, there's no base on that ln, but we do know there's a base of e. So I'm going to take the base of my ln, which would be e, to the $, equals smiley face. Okay, so I could put a little e down there if I need to. Then let's convert this one. So it would be based on my ln, which is e. So e to the 0 is in fact 1. Now let's try going backwards. I got e to the 4th is 54.6. Now I need to convert that to the natural log form. Well, normally, if we would have converted this normal, it would have been log base e of 54.6 is equal to 4. So remember, logs are always the answer, is always the exponent of the exponential. Well, log base e, we know that's ln, right? So I'm just going to rewrite that. ln of 54.6 is equal to 4. So a natural log should always have an e in exponential form, and then e should always have a natural log in log form. Okay? So knowing that they are different, they basically follow the same rules of what you just were doing with regular logs. It's just that there's a kind of that special case that can show up here and there. So, what if I want to solve with an e and an ln? Well, you're going to get a whole bunch of decimals, but that's okay. So I got e to the x plus 1 is equal to 148.413. So I need to convert to natural log form. I need to go to ln. So I know it'll be log base e, right? Because that's the base of my log, but technically that's just an ln. ln of 148.413, and that's equal to x plus 1, because the exponent, right? Well, I need to know what is ln of that really stupid number. So ln, there should be an ln natural log button on your calculator. You just need to find it. It should be near the log button. So I'm going to go 148.413. Enter. So I get a value of, holy buckets, that's basically 5. 4.999999999. Yeah, we're going to go with 5. So 5 equals x plus 1. So I get x is 4. Now, e's, you don't have to worry, but you could plug that in. So it'd be e to the 5th, basically. So if I do that, e to the 5th, I get 148.413. So it checks out, but you don't need to check inside of an e, kind of like we didn't have to just check when we were solving exponential equations. Now, let's try when we're in logarithmic. Let's go to exponential. So I have ln of x is equal to that value. So I need to go to exponential form. So I'm going to go e, right, because that's the base of this natural log. So e to the 2.639, and that is equal to x, the inside. So I need to go on my calculator and find e to the 2.639. Basically I get 13.999 is equal to x. Now, same rules apply with natural logs as they do with logs. So, I'll make a little note of that. Same rules apply. Logs cannot, and I repeat, cannot be negative or 0 on inside. Okay? So, if I take that 13.999, I have still a positive number. That's fine. You could type into your calculator ln of 13.999, and you will get a value of 2.639. So you can check to make sure you actually do get the correct value, so you can make sure you do well on quizzes. Now, evaluating in your calculator. This is just a pure, can you use your calculator correctly? So negative 2 times ln of 4, you should get a value of negative 2.7726. Okay, so double check that. Make sure you're going to get that value. 3 times ln of basically 6, right? So this is 5.3753. This is just making sure, do you know how to type into your calculator? 1 plus 4 times ln of 6. So I got to go 1 plus 4 times natural log of 6. I get a value of 8.1670. Negative 3 times ln of 10. End the parenthesis, so make sure, guys, with this one you end the parenthesis there. Plus 1. You should get a value of negative 5.99. Where's my decimal point? There you go. 9078. Then you're going to want to pause. Try the last two on your own here before I give you the answer. So pause the video and see if you can get those answers on your calculator before I give them to you on the computer. Okay, you should have unpaused me. Waited a long time for you in case you didn't. So this one we should get a value of 7.6009. And then the last guy you should get a value of 6.6609 as well. So making sure you know how to use the natural log button on your calculator. They're definitely not as nice because the base of e, you can't really do those ones in your head. So you need the natural log button on your calculator to evaluate that information. But with that, that's the end of this video. See you later, Sabers.